Assalamualaikum. My name is Muhammad AIMAN bin Muhammad DESA. We from Group 6. I will present for assignment 2. The title is Computer Vision Course Assignment Image Feature Extraction for Mechatronic System. For our group member is Muhammad AMIRUL HAZIQ bin SUDERMAN, DINI NAJMI bin Muhammad ZAKARIA, me Muhammad AIMAN bin Muhammad DESA, Muhammad ALIF bin Abu Bakar, and the last is Muhammad AZIZI AMRI bin Muhammad AMIRUL SHAH. For the next part is introduction. The computer vision is a technology that enable computer to analyze and understand image automatically. In modern industry, computer vision systems are widely used for quality inspection, object detection, and automated sorting process. In manufacturing environment, fastness such as machine board, hex nut, and flat washer are commonly used. However, manual sorting of these components can be time-consuming and prone to human error. Different operators can classify parts differently, and fatigue can further reduce accuracy. Next, the main objective of this project is to develop automated vision system that can be identify and clarify this fastness accurately. To achieve this, image of the fastness are acquired to process using MATLAB. Important shape feature such as elongation, compactness, and HU moment are extracted and used for classification. Is problem statement. The problem addressed in this project is the inefficiency of manual fastness sorting in industrial environment. Manual inspection can be slow and prone to human error, especially when fastness appear in different orientation and size. Therefore, an automated computer vision system is needed to classify fastness accurately and improve production and consistency in manufacturing processes. Thank you. That's all for me.
Assalamualaikum and very good day to you, Dr. Rosli. My name is Muhammad AMIRUL HAZIQ bin SUDERMAN, and for my part, I will be explaining about the methodology. So, for the first part of this methodology, I would like to explain about the overview first. So, the first one, as you can see here on the top one, is the image acquisition, which is the datasets generation. And then, carry on to the next one. The second one is the image pre-processing. And then after that, the third one is the feature extractions. The fourth one is the classification logic, and the last one is the classification result. I will be explaining each of these steps after this. So this is the first part of our methodology. So the first one is the image acquisition, which also the dataset generations. So the first one is the data augmentation. So here are the three samples of our images that we have taken from the Google. And also for the augmentation, we have divided onto several augmentation, which is the first original picture and then the horizontal flip. We have applied this, the horizontal flip, the vertical flip, the scaling, which is the 0.6, which is being smaller, and then the scaling of 1.4, which is bigger. And then by doing this, all the data augmentation, we have generated 15 test images, which will be inserted onto the MATLAB. And then for the image pre-processing, so how we are doing the pre-processing? So the first one is the RGB image, which is the original picture, and then we convert it onto grayscale conversion, and then we do the thresholding, the binarization, and also the last one is the noise removal. And here are the some MATLAB functions that we have used in this project, which is the RGB to gray, gray threshold, gray trash, binarize, and also B-way open. So these are all the methodology for the first three parts. So next, I would like to talk about the feature extraction. So there are three features that we have used in this project, which is the elongation, the compactness, and also the last one, the hue moment. So what are elongation? So as you can see here on the left side, this is the formula, the max of the bounding box divided by the minimum of the bounding box. So what are the function of the elongation? So basically it detects the any elongated shapes of all the 15 datasets or 15 pictures that we have generated earlier. And then the next one is the compactness. So the compactness, the formula for the compactness is the perimeter square divided by area. So what does compactness do? It measures the boundary complexity, uh, how complex the boundary of all these images are. And then the last one, the hue moment. So the hue moment, basically, it detects the rotation and also the scale, invariant, shape descriptor. So here are the three feature extractions that we have done. So this is the last part of the methodology, which is the feature extraction. As you can see here, here is the flowchart on how does the system detects and how does the system gets back the feedback all of these images, all of those data sets, 15 pictures I've said earlier. So as you can see on the top one, which is start the oval shape, the object is detected. And then carry on to the next one, it calculates the elongation, also the compactness. So the next one, if the elongation is larger than 2.0, then the classification of that picture will be classified as the machine bolt. If it is not more, the elongation is not more than 2.0, it will detect the compactness. If the compactness is larger than 18, and then it will be detected yes, and also it will be classified as the hex nut. And the last one is if the compactness doesn't detect it larger than 18, it will carry on to the next one, the no, and finally it will be classified as the flat washer. So basically, these are all the methodologies that we have applied. And after this, in Alif's part, he will be demonstrating the MATLAB on how we do this project. Thank you and Assalamualaikum.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ali bin Bakar and my matrix number CA240141. And I will be presenting the results and discussion section followed by a demonstration. Let's start with the visual proof. As you can see in figures 1, 2 and 3 on this slide, our preprocessing pipeline using auto thresholding successfully isolated all three fastener shapes. Most importantly, it perfectly preserved the important internal boundaries, specifically the holes in the nut and washer, which is essential for our accuracy. Moving on to the data proof feature robustness, this is our summary of our data. And 100% accuracy, the logic engine achieved a flawless classification rate across all test variations. And next, for the rotation invariance, flip object, which is horizontal or vertical, were perfectly classified because agent probes calculates the features relative to the object's center of mass. And last but not least, for the scale invariance, ratio-based features, elongation and compactness remain highly stable even when objects were scaled up to 140% or down to 60%. And for the next slide, we go to the demonstration. Okay, this is our code from Group 6. And then to fulfill the demonstration requirement, let me briefly explain our algorithm pipeline inside the MATLAB code. After pre-processing the image, we use the region props function right here to extract the bounding box area and perimeter of the objects. Then, as you can see here, this is if else. Using this, we manually calculate elevation by dividing the maximum dimension of the bounding box by its minimum dimension. Next, we calculate the compactness using the formula perimeter squared divided by area. Finally, we extract the HU moments, specifically theta 1. These three extracted features are then fed into our cascading if else logic gate below to classify the objects. And then now I will run a demonstration. First, I am testing the base image of bulb underscore 01 underscore original of the mission board. Then I will run this code. As you can see here, we have the result of the original picture, and we got the segmented binary. And for the segmented binary is very clean. If we look at the common window, the elevation scored 2.63. Because this easily passed our threshold of 2.0, the system correctly classified it as a mission board. And then I would like to test another part, which is the not underscore 04 underscore scale underscore down. To demonstrate that our system is scale and rotation invariant, I will now test a hex nut image that has been scaled down to 60% of its original size. And then I will like to click the run. And as you can see here, this is our picture of the original hex nut and the segmented binary. After that, even though the raw pixel count is much lower, look at the common window. The compactness score remains highly stable at 60.622. Since this is well above our logic threshold of 18, the system perfectly classifies it as the hex nut. And for the conclusion, our demonstration and our dataset testing, which includes all 15 variations documented in Appendix D of our report, prove that combining shape-based ratio with HU moments creates a highly reliable and robust computer vision model. Thank you.
Assalamualaikum to Dr. Rosli. My name is DINI NAJMI bin Muhammad ZAKARIA, and I will explain about Sustainable Development Goals (SDG), and our project are related to SDG 9, which industry, innovation and infrastructure. So our focus, upgrading all the industrial system to make them smarter, cleaner and more efficient. And next, we target to moving away from manual sorting. Traditional sorting by hand is slow and cause mistake. So replacing it with computer vision bring modern innovation to factories. Our next point is affordable innovation. So instead of using expensive power-hungry deep learning AI, our system use simple shape and geometric math in MATLAB. And the big benefit is it proves that small and medium business SMEs can automate their factories sustainable without buying expensive high-energy hardware. So for next part is impact of vision system on industrial automation efficiency. First is continuous production. Unlike target human eyes, the MATLAB system runs non-stop with 100% accuracy, even if the parts are rotated or upside down on the conveyor belt. No more assembly bottlenecks. For second point is cutting down material waste. In manufacturing, picking the wrong part, like mistaking a washer for a hex nut, ruins product and create metal scrap. Sorting them correctly beforehand can save the raw material. And for third point is saving electricity, low carbon footprint. It is because the code used fast, lightweight, math. It doesn't need a heavy GPU or cloud server. It runs instantly on a basic factory PC or small microchip, keeping energy bills very low.
Assalamualaikum. My name is Muhammad AZIZI bin Muhammad Malaysia, CE240065. Now I'll continue my part of the conclusion. So in the conclusion, we can say that our project is successfully developed a computer vision based fastener classification system by using the MATLAB. So the system extracts shape feature by using elongation, compactness, and hue moment. So based on the result, the system is achieve a 100% classification accuracy, which is first measure mode, second hex nut, and third is flasher washer. So the all accuracy for the all 15 test image we already on the result. So this is a proof. Sorry, for the system implemented under the image flipping and image scaling also. So there's a proof that the selected feature are the robust and reliable. So individual improvement, classify more type of the industrial component. Second, test under the real factory condition. Third, in integrate machine learning and or AI for the highest flexibility for the scan for the fastener classification. And the last is apply in automated sorting and manufacturing system for the industrial automation application. So that all for us. Thank you for uh, learning team presentation. Thank you, Doctor.